The second property that we will study is electronegativity. What's meant by electronegativity? The ability of the atom in covalent molecule to attract the electrons of the bond toward itself. In this case, the electronegativity of chlorine is higher than that of hydrogen, so hydrogen will attract the electrons of the bond toward itself. Let's talk about the graduation of electronegativity of elements in the periodic table. First, in periods, as you can see, by increasing the atomic number from left to right, the electronegativity increases, as you can see from this scale. But in groups, by increasing the atomic number from up to down, the electronegativity decreases, as you can see from this scale. From up to down, electronegativity decreases in groups by increasing the atomic number. According to the previous information, we can conclude that fluorine is the highest element in the electronegativity. This is because it lies at the top right hand side of the periodic table just before noble gases. So fluorine has the highest electronegativity, which is equal to 4. We can classify the types of bonds according to the difference in electronegativity as follows. As you can see from this video, these are the electronegativities of some elements. What are the types of bonds according to difference of electronegativity? The first type is ionic bonds, and this occurs if the difference between the two elements forming the compound is more than 1.7. Like this between sodium and chlorine and sodium chloride, the difference between them is 2.1. The second type is covalent bonds, and we have two types of covalent bonds. If the difference in electronegativity is less than 1.7, it is a covalent bond. And if the difference is relatively high, which means near 1.7, so we have a polar covalent compound. But if the difference is relatively low, which means that it is much more less than 1.7 and approximately equal 0, so it is nonpolar compounds. If the difference is 0, so we have pure covalent bond. Ionic compounds. They are compounds in which the difference in electronegativity between elements forming their molecules is higher than 1.7. Examples: sodium chloride. The difference between sodium and chlorine is 3 minus 0.9, which is equal to 2.1. 2.1 is more than 1.7, so the bond between chlorine and sodium is ionic bond, and sodium chloride is an ionic compound. Polar compounds. They are covalent compounds in which the difference in electronegativity between elements forming their molecules is relatively high. Examples: water, H2O, and ammonia, NH3. As you can see, the difference between electronegativity of hydrogen and that of oxygen is equal to 1.4, which is less than 1.7. But it's still relatively high, so water is a polar covalent compound. Nonpolar compounds. They are covalent compounds in which the difference in electronegativity between elements forming their molecules is relatively low. Examples: methane, CH4, hydrogen sulfide, H2S. We will see that in these two cases the difference between carbon and hydrogen is 0.4, and between hydrogen and sulfur is 0.4, which is relatively low, so they are non-polar compounds. Problem: calculate the difference in electronegativity between the two elements forming ammonia molecule. Then identify the type of bond between them. First, we have to know the chemical formula for ammonia. The chemical formula for ammonia is NH3. So we have to calculate the difference in electronegativity between hydrogen and nitrogen. The difference between them, don't worry, the numbers will be given, is 3 minus 2.1, so the difference between them is 0.9, which is relatively high. So ammonia is considered a polar covalent compound, and the bond between nitrogen and hydrogen is polar covalent bond. Let's talk about the third and final property, which is metallic and non-metallic property. Elements in the periodic table are classified into four main kinds, which are metals, nonmetals, metalloids or semi-metals, and noble gases. Let's compare between metals and nonmetals. The first point of comparison is the outermost energy level. The outermost energy level in metals contains less than 4 electrons, but in nonmetals it contains more than 4 electrons and less than 8 electrons. During chemical reactions, metals tend to lose electrons and change into positive ions, while nonmetals tend to gain electrons and change into negative ions. Examples: for metals, sodium Na11, magnesium Mg12, aluminum Al13. For nonmetals, we have fluorine F9, chlorine Cl17. Let's talk about metalloids or semi-metallic elements. What's meant by metalloids? They are the elements which have the properties of both metals and nonmetals. Note the following. It is difficult to know the metalloids from their outermost electrons. This is a give reason question. Give reason 4. It is difficult to know the metalloids from their outermost electrons because they vary from 3 to 6. The number of electrons varies from 3 to 6 electrons. So we have to memorize them. We have only 4 examples for metalloids. Bromine, its outermost energy level contains 3 electrons. Silicon, its outermost energy level contains 4. Arsenic, its outermost energy level contains 5 electrons. Trillium, its outermost energy level contains 6 electrons.